Hi, this is an equations video looking at a few key examples of inequations. Inequations have inequality signs here. We've got a less than sign in this question when I can flick back to it. Okay, they're solved very similarly to normal equals equations, but with one exception we'll get to in the next example. So here we'll look to get the x on its own, and we want to move this plus 3 by minusing 3 both sides. Leaves us with 3x on the left hand side. When those cancel each other out, a plus 3 and a minus 3 is less than 6 minus 3, which is also 3. A lot of 3's in this question. Let's try and get x on its own by dividing by 3 both sides, and we'll get x is less than 1. So not much happening here other than what would happen for an equals type equation. Just the inequality sign that was a less than stayed as a less than in that situation. Nothing much happened. Here though, something interesting happens. According to a special rule that we have for inequations, we want to move the numbers away from the letter here. Let's start off with this one here. This is a positive 8 at the moment, so if we want to move that, we're going to have to minus 8 both sides. Now that minus belongs to the 2a, so we'll have to make sure we keep it belonging to the 2a for now. So that's minus 2a is greater than, now 7 minus 8 is minus 1, we're taking away 1 more than we have there. Now that minus 2 is multiplying by the a, so we'll be dividing by minus 2 to get rid of that and leave the letter on its own. Now there's a special rule that says if you multiply or divide by a negative in inequations, we swap the direction of the arrow. Swap the direction of the arrow. I'm saying arrow there, but I'm really saying what direction the inequation sign is going to go. So at the moment I have minus 2a is greater than minus 1. When we divide by minus 2, we'll have a on its own there, and this direction sign, instead of being greater than, is now less than, and we just calculate the right hand side. Minus 1 divided by minus 2, and minus divided by minus is a plus. It'll just be 1 divided by 2, or a half there. So because we were multiplying, well actually in this case we were dividing by a negative, the direction of the inequality sign swaps to be the opposite. Okay, on this one now, if this was a normal equation, our first step would be to move the smaller letter term first. And can you see that out of those two letter terms, it's the 4n that's the smallest. So let's start off by minusing 4n both sides. That'll leave us with minus 5, that minus belongs to the 5, is greater than, now 7n minus 4n is 3n, plus 10. Okay, we'll try and get the letter on its own. We'll try and move a plus 10 by doing the opposite to both sides. Minus 10, that on the number line gives us minus 15, is greater than 3n. We'll need to divide by 3 both sides to get the letter on its own. We get minus 5 is greater than n. Now we'd want that n to come first, so we'll just mirror reverse all that. N is less than, see if you go from the n, it's got the smaller arrow bit next, so if we mirror reverse that just to get the n first, that's what happens. Now we didn't kick in at any stage, at no stage there did we multiply or divide by a negative. We're just changing the direction of the arrow because we're going to want the n to be listed first. So that's just a mirror to reverse type thing. We didn't really kick in that special rule there. Here now, this is a triple type question here. We've got 2 inequation signs and 3 sort of sections of our terms here. Now we want to get the letter on its own, so what we're going to do, whatever we do to get the letter on its own in this middle bit, we'll have to do it to the other two sides as well. So we're going to minus 4 in every section to be fair. We'll get a minus 7 on that first section. Minus 3 minus another 4 is minus 7. Less than or equal to, and we'll just have 5x in that middle section because a plus 4 and a minus 4 will cancel each other out. And 6 minus 4 is 2. So let's just recap there. We wanted to move the plus 4 and the 5 that's multiplying eventually, but we wanted to move the plus 4. We have to do the opposite to it, and we have to do it to every term. Okay, to get the x on its own now, we want to move a 5 that's multiplying, so to do the opposite we'll divide by 5. When we divide by a number, we can just write it as a fraction with that dividing number on the bottom. So the bottom of any fraction divides into the top. So we're going to have minus 7 over 5 for that bit. That symbol there, and these will cancel out, a 5 that's multiplying and a 5 that's dividing, leaving us with x. And we can make a fraction out of 2 being divided by 5 as well. Okay, not a very even type of answer, but that's how it came out. So we want to get the letter on its own still. Whenever we do anything to that middle section, we have to do that same thing to those other 2 sections of the inequality statement there too. So it's an interesting answer. Minus 7/5 is less than or equal to x, which is less than 2/5 there. Okay, next one. Now, a bit like in our equations with lots of numbers on the bottom, I like to get rid of those numbers on the bottom pretty sharply, as in the first thing that I want to do. I want to multiply every term or every section here, every chunk, by a number that 5 and 2 both go into, and I'm going to choose 10. When I do some cancelling then, 5 goes into itself once and into there twice. Like in the equations, the surviving number up the top after the cancelling is done expands through, a bit like we would have had brackets there. So it's 2 times whatever's on the top. So we'll create a couple of terms there, 2p plus 6 when the 2 expands through there properly. Let's be careful with this second bit because we've got a minus in there. Anytime we've got a minus in front of some brackets, we've got to slow ourselves down and be careful. 2 goes into the bottom once and into the top 5 times, so we'll be expanding that through that bracket there. But remember, we've got a minus we've got to take care of here, so it's almost like we've got a minus multiplying through the bracket there. Minus 5p, and minus 5 times minus 4 is a plus 20. And on this right hand side we've got a greater than or equal to sign, and then we've got 10 times 2 is 20. There's no cancelling down there. It didn't have a bottom number that was shown there. Alright, quite a bit there. We've effectively, by multiplying through by 10, we've effectively got everything on the same line there, which is a good move. Let's join some like terms here before, and we'll just simplify this a little bit. 2p minus 5p is minus 3p. Plus 6 plus another 20 is plus 26. And we've got a 2-step inequation here. We have to be a little careful. There's a little bit of a trick coming up here. Let's get the letter on its own by moving the plus 26, and to move a plus 26 we do the opposite to both sides, minus 26. Leaves us with minus 3p. They'll cancel out. Greater than 20 minus 26, we're taking away more than we've got there. Leaves us with minus 6. Now, watch out for this bit. We will be dividing by a minus 3 both sides, and when we multiply or divide by a negative we have to swap the arrow direction of the inequation sign. So that's our little trick for inequations here. P will be left there. We have to switch the inequation sign and then calculate the right hand side. Minus 6 divided by minus 3 is a 2. Quite a bit happening on that one too, isn't there? Another example here. This might be our last one. Can you see what we'd need to multiply everything by here to get rid of a 2 and a 3? Let's multiply every little section by 6. Don't forget any of the sections. Okay, 2 goes into itself once and into there 3 times, and then we think of that as expanding through that bracket, so we will have 3 lots of r and 3 lots of minus 4, which is minus 12, is greater than 6 lots of 5 is 30. There's no sort of cancelling down that needs to be done there. 3 goes into itself once and into 6 twice, and then that multiplies by the top there. So we've got 2 times 4r, which is 8r. Now we're left with, at least everything's on the one line and we haven't got anything underneath to confuse ourselves there. But we do have letters on both sides, and we should probably move the smaller letter term first, so we'll minus 3r there. That'll leave us with minus 12, because a 3r and a minus 3r will cancel out. It's greater than 30. 8r minus 3r is plus 5r. Let's get the r term on its own by moving the 30. It's a plus 30 at the moment. Let's minus 30 both sides. Gives us minus 42 on the left hand side is greater than 5r. Let's divide by 5 both sides. At no stage are we multiplying or dividing by negatives, so we don't have to do any switching around for that reason, but we might have to switch around because we want the r to be listed first. So we'll have minus 42 over 5 is greater than r on its own, because these would cancel out. So that would just be, I'll just put the arrow up here. If we want the r to be listed first, we'd sort of read from the r where the r is, and this would have to sort of mirror reverse here. So r is less than minus 42 over 5. Alright, so very similar techniques to the equal signs, but remember the main bit to watch out for is if you multiply or divide by a negative at any stage in your working out, then the arrow direction changes, such as greater thans turn into less thans, or less than or equals will then turn into greater than or equals. So that's the main bit to look out for. That's the main difference between equations and inequations. Hope that helps. PeterBlakeMaths.com. Catch you in the next video. See you later.